Yeah, welcome back. Welcome back, everybody. Today we continue with triangles and polygons. In case you missed the first class or you just joined us, copy the scheme of work. That's our guide. Make sure you copy it neatly in your notes, and you can check. You can send me a request, and I'll share a link to our last lesson with you, so you can copy that. You can copy that note too, and also learn the previous theorems we talked about. Now here, today is 17. And we're continuing with triangles and polygons. We're actually still on interior and exterior angles of triangles and polygons. Triangles and polygons. Now, the theorems we're taking now, we're just going to state them. We don't need to go through the proof. You can check that in your textbook. It's quite simple and self-explanatory. Now here, our third theorem is the sum of the interior angles. The sum of the interior angles. That means the angles inside any n-sided polygon of any n-sided, and any here means whether convex or not, whether regular or not. Any n-sided convex polygon. Any n-sided convex polygon. Any n-sided convex polygon is 2n minus 4 right angles. 2n minus 4 right angles. And that's the same as, or I want to say, or n minus 2 times 180 degrees. That's the same as n minus 2 times 180 degrees. And our second theorem, which is theorem 4, we just take these two theorems and then examples. Our second theorem states that the sum of the exterior angles, you know what an exterior angle is. It's an angle formed by extending a side of a polygon. If you make a side of any polygon longer, the angle so formed is called an exterior angle. Of the exterior angles of any convex polygon, any here is stressed, because whatever that kind of polygon is, this rule applies. Of any convex polygon is 4 right angles. I.e. 360 degrees. Of course, you know that 4 right angles is 360 degrees. The right angle has a size of 90 degrees. So 4 right angles is 360 degrees. Now straight we go to an example. That's our first example actually today. Example 1. ABCDE. ABCDE is a regular polygon. The sides AB and DC are the sides AB and DC are produced. That means they are made longer, are produced to meet at X. Show that triangle PDX has two equal angles. If triangle BDX has two equal angles, that means triangle BDX is isosceles. So what they are saying here invariably is that we should show that triangle BDX is an isosceles triangle. And now let's see, how do we do that? Let's have a solution. I want to paste the diagram. I think I saved it somewhere before. That's the diagram. Now we start this way. In triangle BDX, angle Y is the same as angle Z, because they are both exterior angles of a regular polygon. Or let me state the regular polygon. They are both exterior angles of the regular polygon. The regular polygon ABCDE. The exterior angles of any regular polygon are equal. So Y and Z will be equal here. Now, then I can say in triangle, okay, before that, let me find the size of that exterior angle. Therefore, and I know that Y equals sum of exterior angles. Each exterior angle of a regular polygon or of any polygon is given by sum of exterior angles over number of sides. Each exterior angle of a regular polygon is given by the formula sum of exterior angles, this is short for exterior, all over number of sides. That's what you do to find the size of each exterior angle of a regular polygon. Number of sides. And that means we just talked about that, the sum, and I think that was in theorem 3. The sum of exterior angles of any convex polygon is 360 degrees, and divided by the number of sides of a polygon ABCD is 5. So that means Y is equal to 72 degrees, which means Z is also equal to 72 degrees. Now we can find the value of angle X in triangle BXC. So in triangle BXC, angle X plus angle Y plus angle Z equals 180 degrees. Angles in a triangle. Sum of angles in a triangle. And that means 72. No, X is unknown. X plus 72 plus 72 equals 180. And that means X plus 144 equals 180. Which means X equals 180 minus 144. And that means X equals 36 degrees. X equals 36 degrees. And that means, so that's X, but that's not where we're not there yet. We actually want to show that. I want to paste the diagram here so that we can see it as we continue with the solution. Now, we actually want to show that triangle BDX has two equal angles. Now, what else do I need? I can say that angle y equals a plus c. And what's the reason for that? That's in triangle BCD. In triangle BCD, angle y equals a plus c. And what's the reason for that? Exterior angle of a triangle. The exterior angle of a triangle is equal to the sum of two opposite interior angles. I love writing the cursive F. Now here, so how do you determine what angles are opposite interior angles, or which angles are opposite interior angles to an exterior angle? Of course, this is triangle BDC. You can see that this is triangle BCD. That's triangle BCD, and this. So this angle here is an exterior angle to it because it is formed by extending line side DC of triangle BCD. So what you do to determine the angles that are opposite interior to this exterior angle is complete this part. This is what you need to add to y to make it 180 degrees. So once you complete this part, the remaining two angles inside the triangle will be the interior opposite angles, and those are A and C. So that's how to determine the interior opposite angles to an exterior angle of any triangle. So that's that. Let me erase this for my diagram to be clearer. So that means the opposite interior angles of angle y, of the exterior angle y, or to the exterior angle y, are A and C. So y is equal to A plus C. And that means, so I can use the same letter, but I know that A is the same as C, since triangle BCD is isosceles. A equals C because they are the base angles of triangle BCD. Base angles of triangle BCD. Base angles of an isosceles triangle are equal. So I can now say y equals A plus A. Since A is the same as C, you can write C where you're supposed to write A, or A where you're supposed to write C. But I chose to write A for C. So that means y equals A plus A. And we know that y is 72. That means y equals 72 over 70. That means 72 equals 2A. And we divide both sides by 2, which means I'm going to push my diagram further down. So that means A is equal to 36 degrees. So, and they said we should prove that BDX has two equal angles. Now I've been able to show that A, which is an angle, look at that, triangle BDX, has two angles that are the same, which are A and X. So we're done with the proof. So I can say that A equals X, which is 36 degrees. And therefore, triangle BDX has two equal angles. And that's a proof very, very, very simply. Once in a while you have to do some proofs, but it doesn't mean they are difficult. So now let's take another example 2. That's our second example, and then you have an exercise. This time you're going to send your work to me immediately before you leave the class. So let's take one question. A regular polygon has angles of size 150 degrees each. How many sides has a polygon? A regular polygon. Take note of the word regular. A regular polygon. A regular polygon has angles of size 150 degrees each. How many sides of size 150 degrees each? How many sides has the polygon? How many sides has the polygon? That ends in a question mark. How many sides has the polygon? That's our second example. Let's see that solution. A regular polygon has angles of size 150 degrees each. How many sides has a polygon? We know that if a polygon is regular, that means its interior angles are equal. Its interior and exterior angles are all equal. Are all equal. So, and we know there's a formula that says each exterior angle is equal to sum of exterior angles over number of sides. Alright, so this is what I'm going to do. That's the formula I'm going to use to obtain the polygon. If you don't know the number of sides of a polygon, you can sketch it this way. I don't know the number of sides the regular polygon has. So that's why I'm doing this. This broken line shows that the number of sides of a polygon is not complete. Now, each has angles of size 150 degrees each. That means each interior angle is 150 degrees. This will also be 150. This is a sketch, mind you. 150 degrees. 150 degrees. And this will also be 150 degrees. So, what does that tell you? Let me say, let x be equal to each exterior angle. If x is each exterior angle, that means this is x, this is x, this is also x. So what do we now do? We can say x plus 150 degrees equals 180 degrees. Angles on a straight line. Angles on a straight line. Of course, you can see that this line is straight. So these two angles, 150 and x, will add up to give 180 degrees. Now, that means x equals 180 minus 150, which is equal to 30 degrees. So that means each exterior angle is 30 degrees. So we can say, therefore, and you know the number of each exterior angle, the formula for finding the size of each exterior angle of a regular polygon is given by sum of exterior angles divided by number of sides. What that simply means is that the number of sides is also given by number of sides. Therefore, number of sides Therefore, number of sides is given by sum of exterior angles divided by each exterior angle, which in this case is 360 degrees divided by 30, and that's 120 degrees. What am I saying? That's 12 sides, sorry. That's 12 sides. That means the polygon has 12 sides. And that's it simply. Therefore, the polygon has 12 sides. The polygon has 12 sides. And that's it. We take what I'm going to call, what's going to be our, let's see. Okay, I think we've had enough examples. I think that should, these two examples should suffice for an exercise too. Should suffice for an exercise for now. So let's take an exercise. Now, exercise number 1. Find the interior angles of a regular polygon which has, find the interior angles. Find the interior angles of a regular polygon. Find the interior angles of a regular polygon which has, this is very simple, please don't say you don't understand, I'm sure it's a piece of cake, which has, find the interior angles of a regular polygon which has A, 6, B, let me put it this way, which has A 6, B 10, and C 20 sides. Now number 2, the angles of let's see number 2, the angles of a quadrilateral taken in order. The angles of a quadrilateral taken in order. Order here means in order of sizes, in ascending according to their sizes, from the smallest to the biggest. Taken in order are x, 5x. Oh no. Order here means, starting from a point and going round to the last one. It doesn't mean of sizes. It doesn't mean order of sizes. It's just starting from a particular point and going around the figure to the last one. X, 5x, 4x, and 2x. That means when you are arranging the polygon, you're going to go this way. X, maybe this way, x, 5x, 4x, 2x. And that's all. So you start from 1 and follow this arrangement to the last. X, 5x, 4x, and 2x. Full stop. Find these angles. Find these angles. Find these angles. There's another question. Draw a rough sketch. Draw a rough sketch of the quadrilateral. When you find the sizes of the angles, you have an idea what kind of quadrilateral the figure is. Draw a rough sketch of the quadrilateral. That's another, and there's another question. What if you can sketch it, then you can tell what kind of quadrilateral it is. What kind of quadrilateral? What kind of quadrilateral? What kind of quadrilateral is it? What kind of quadrilateral is it? I think we can take a last question. And this might be a bit... Anyway, what is the value of x in the angle? What is the value of the angle marked x? This might be a bit tricky, but it doesn't make it difficult, I can assure you. It's just... Okay, don't let me give you this as an exercise. I'll give you that as a homework. 4, this is going to be number 3. Let's see, what are we taking? Let's see, what are we taking as question 3? The angles of a triangle are an isosceles triangle, an isosceles triangle, an isosceles triangle is such that each of the base angles is twice the vertical angle. The vertical angle is the last angle that's not a base angle. It's twice the vertical angle. Find the angles of the triangle. Find the angles of the triangle. Find the angles of a triangle. And that's it, simply. So you are solving these questions right now and sending to me. I think we're going to have 2 periods today. So solve this very quickly and send to me for inspection. I'll mark it and then we'll do a correction before moving on. All right. I hope you enjoyed the lesson. And that's where we continue from in our next class. Stay safe and be